Wizard Power. So we've got the Executive Chairman, Tony Roby, here. So Wizard Power's developed Big Dish, a world-leading concentrating solar power technology that converts solar energy to electricity over 50% more efficiently than any other CSP technology. Big Dish provides the world's most competitive on-demand utility-scale solar energy. Please welcome Tony to the stage.
Good afternoon. Thank you to Steve and his crew. Lovely to see you all here, and thank you to Pricewaterhouse. So Steve's done a pretty good job. He's told you what we do, and really all you need to do now is invest in it. But I'll tell you a little bit more because I've got 10 minutes to fill in, and so I'll do something with it. So in 2005, I stood in front of what was then the ANU's Big Dish, slightly different than the photograph you see there. That's one of our big dishes. And they told me what an interesting technology it was, all the advantages it had over the other concentrating solar technologies, the fact that it's just simple physics, so you don't have to debate it. And so my first question for them was why I wasn't standing at the end of a queue watching all the other people who wanted to commercialise this technology. And they said, well, there's one major problem, they're very expensive. The reason I'm standing here today is because what we've done in the last few years is invented a way of making space frame technology and some other things that go with it, which enormously reduce the cost and provide a whole set of other advantages. There's a little comment on that slide that you see there at the moment. But just before I get to it, I might make the point that for those who are not aware of it, the advantage that CSP offers, there are different advantages for different renewable technologies. And I suppose we just got from the other Tony a touch on two things. One being that obviously he deals with PV, which is nice, sits on your roof, doesn't require a network to be able to power your house and can backfeed into the network. Very useful way of supplementing the network and a very good idea. And when people get away from the idea that the only thing you can have is one great big power station, you begin to see the advantages of that. And the other thing he's got is a biomass solution, which does sit at the other end and is like a very big power station and provides power you need. Those two lots of things together represent the way the world's working these days and the sort of requirements that are needed in a modern network. We also sit at that end, at the big end of the network. And the thing we're most similar to is a gas-fired power station. Just so that people can keep that in their head. And the benefit in all of that is that we provide dispatchable power on demand, which is really where the most important part of the electricity market is for mass generation. Now, in relation to the diagram here, a couple of things worth noting. Whilst we don't need to be there yet, our current plans demonstrate that we can be cost competitive with fossil fuel generated electricity in about 5 to 8 years. Now, there's without doubt, because of for other reasons, there are going to be still various incentives in place before that time is up. But it's worth understanding that that's where our target is. Today, obviously, one doesn't need to be there because there are a whole raft of incentives. I mean, Australia doesn't have that many, but other countries have very solid incentive schemes, and it's quite easy to be competitive in the renewable marketplace, at least if you're us at the moment. We're still a privately held company. Our shareholders range from staff through sophisticated investors, private companies and a publicly listed company. The reason I'm here today is we're seeking to add another $5 to $10 million capital over the next 12 to 18 months, 5 million at least now. And we're going to use that to supplement the income that we've got coming down the line, which I'll talk about a bit more in a moment. Our first major commercial project, and I'll just touch on this briefly and I'll come back to it. Our first major commercial project is the Wireless Solar Oasis, and that starts at stage 1 as a 40 megawatt solar power plant, so it's about the average size that a lot of the concentrating solar power plants are overseas, but they're that size overseas for all sorts of peculiar reasons. But it will end up being around about a 200 megawatt power plant by the time it's completed. Steve told you also that it could be true rather than just something I said, that we're 50% more efficient than any other technology. That little graph over there shows the relative efficiencies of the four forms of concentrating solar power: linear Fresnel, troughs, towers, those are those big towers with the heliostats around them, people aren't familiar with it, and dishes. And there's just a very simple piece of physics as to why dishes are that efficient. There's nothing we've done about it. The Greeks knew about that about 2,500 years ago. Our claim to fame is that we invented a very clever way of making them. We also created some supplementary technologies that assist this process. We have a mirror panel. Previously, most solar reflecting glass is just the glass, so it's a weight that has to be borne by whatever the structure is, trough, whatever else. We reinvented that by making a laminated panel with very, very thin glass on the front. That has some benefits because the glass is expensive, but it also has some benefits because the thinner the glass, the less problems you have with losses. So our latest batch of glass, our glass manufacturer tells us, mirrored glass, is about 95% efficient. This is really important because every one of those last few percent that you can wrinkle out goes to the bottom line of the developer. We then worked out a way of laminating these so that we could make a focused panel, which gives us a very highly focally accurate dish. Each panel is about 1.1 metres square. It produces a focus about this size at the focal point, the receiver that we see up there. And as a consequence, we can have a very small receiver, and that allows us to gain a very high degree of efficiency, or a small entry point to the receiver, it doesn't matter how big it is past that point, which allows us to have a very high degree of efficiency there as well. So part of our claim to fame is also that we produce extraordinarily efficient technology. In addition to them, I should point out, the mirrors are basically unbreakable. We do a nice demonstration where we whack into them with a large mallet. We also try to do some things that aren't that scientific, just to entertain the public. And then, in addition to that, they're structural. So whatever structure they go on, they contribute to the structural integrity of the particular thing. And as a consequence, you end up with a lighter structure. So the 500 square metre dish, which is what that is, and you can see that little person down the bottom. No, it's not a dwarf. He's about 6 foot 4 inches tall, so it gives you an idea of the scale of the dish. That 500 square metre dish weighs less than its predecessor that was a 400 square metre dish. And a big part of that is the structural part of the mirrors. Now, in addition to that, we also have a storage technology, which at the moment we're not proposing to use in any of the foreseeable plants, only because it adds to the cost at the moment. However, it is the world's most efficient heat-based storage system. And so there will come a point along the way, hopefully in the not too distant future, when we can start to include that. At the moment, we basically dual fuel our power plants to get the biggest return for the investor, and that alternate fuel will normally be some form of gas, either got from a renewable source or just a normal gas. Can't think of the appropriate term, but you know what I mean, like the stuff that comes into your home and you cook with. A natural gas, thank you. It's such an unnatural thought, natural gas. So all of this adds up to a very nice wealth of IP that we have, and that's one of the things that makes us different from the very few companies that are in the concentrating solar space. We own a very large amount of IP, and that IP protects the niche we have, which is the very high temperature niche in which we live. Our dishes' performance range from around 500 degrees to over 1700 degrees centigrade, and the top end of that has nothing to do with power production. That's for the thermochemical world we're all moving into, which I'll talk about on another day. Otherwise Steve will shoot me because I know I'm sure I'm going over time. So I'd just like to move on a little bit here and just talk briefly about the market. The market is very small at the moment. It's only a very new market, as you can see. Back in 2010, there was hardly anything. It's currently growing at about 40% growth rate per annum. These numbers come from the International Energy Agency, a relatively conservative organisation. A few years ago, they didn't even talk about solar. By 2030, that's a $500 billion construction market worldwide. It's a fairly rapid growth rate when we begin to get into some of those things. We are currently, as I said, building a power plant, which refers to there, but the interesting thing for us is we've got a pipeline which is about 4 gigawatts, and at the moment that would be more than the total installed base of concentrating solar in the world. You might wonder how that's possible, so I'll talk about a couple of the places in the world where this is happening at the moment. We've got India planning to build about 22 gigawatts of solar, both CSP and photovoltaic, by 2022. That means they really have to be into it now, and they are. And then most recently, we've got our little friends from North Africa, and the Saudis around announcing 27 gigawatts. That's about $100 billion worth of development, because they've noticed they've got a lot of sunshine and they can make a lot of money from their oil and gas if they sell it to someone else. I won't spend a lot of time here. I just want to mention the business model. We've got a very simple business model. We license our IP. We do make the mirrors, but other than that, all we do is license IP and provide consulting. And we've done this on purpose because with the sort of growth rate we've got in front of us, there's no way we could ever grow a company to match that growth path if we did anything other than follow a business model like this. There are lots of lovely nuances to our business model. Anybody who'd like to come along and talk to me later, I'm happy to explain it, but it's well worth more than 10 minutes to discuss. We've got a very, very solid partnering model, and that goes very well with that business model. And I'm also happy to talk about that, but we've got partners that range from insurance companies all the way through to all sorts of specialist engineering and other firms, and that's how we assist developers who want to use our technology to put a project in place. So, as I said before, we're just looking to raise a little bit of money here. Anybody who's got that in their back pocket's welcome to come and see me later. What that slide also tells you is that we're expecting to have about $50 million in revenue by June 2015. In that time, we're also expecting to do an IPO and raise another $40 to $50 million. So this may sound like a lot of money, but if you think about the market we're going into and how big it is, it's a very exciting place if you can stay in front. We're currently in front and we plan to stay there, and the way to stay there is to have a cost reduction curve and an efficiency improvement curve, which we have very carefully planned. And just to prove that that's something we can talk about well, I made sure I brought an engineer with me, so anybody who wants to discuss the engineering of our cost reduction path is happy to can come along and have a discussion with Joe, who's here with me. So this is everything you need to remember from today. Very uncomplicated business model that we've got. Works very well, already working very well. And so the last thing I just leave you with is this. Thomas Edison worked this out quite a long time ago. Have a little think about it. If you agree with him, come for a visit. Thank you.